Assalamualaikum, my name is SHARIFAH. My metric number is 2027X6 and I'm from Perth. So I choose RC low pass filter as for the passive filter. Basically in this RC low pass filter it has resistor and capacitor, and the purpose is to alter and eliminate undesired high frequency components, and the reactance change with frequency, resistance remains constant, and the simulating response is observing output signals when subjecting the filter to different input signals. And as for the transfer function, it provides insight into gain and phase characteristic at different frequency. And as for the circuit development, it is constructing circuits to accurately represent the filter's behavior. Okay, next. In the MATLAB, I'm already create the code, and this is the code. I will run in the MATLAB and run the code. From this code, the blue curve corresponds to the input signal, which is the sinusoidal waveform with an amplitude with 5 watts and a frequency of 200 hertz. The x-axis of the graph represent time, and the y-axis represent the amplitude of the signal. And the shape of the input signal can be observed, showing its periodic nature. And the red curve represent the output signals obtained after passing the input signal through the RC low pass filter. The x-axis represent time is the same as the of the input signals. By comparing the input and output signals on the graph, you can observe that the effect of RC low pass filter, the filter attenuates higher frequency components of the input signal while allowing lower frequencies components to pass through. So this attenuation is visible in the amplitude reduction of the output signal compared to the input signals. This is the coding in the MATLAB. I set it to the resistance to the 2 kilo ohms and the capacitor to 3 microfarads, and the time vector for the simulation, and this is the time vector for the simulation. This is the amplitude of the input signal, and this is the frequency of the input signals in hertz. And this is to calculate system response. So I have set the initial condition here, and to solve the differential equation numerically, I put this equation, and this is to generate input signal, and lastly it is the output signal. This is just to plot the input and output signals. I have shown the code in the MATLAB, the output. Okay, let's see the transfer function. Okay, this is the transfer function code, and I run it. It shows the graph of the RC low pass filter for the frequency response and phase response. The first subplot depicts the frequency response of the RC low pass filter. So the x-axis in the logarithmic scale representing a wide range of frequencies from 1 Hz to 10 MHz. And the y-axis represents the magnitude of the filter's response in decibel. The magnitude response shows how the filter attenuates or amplifies different frequencies within the given frequency range. So as the higher magnitudes indicates loss attenuation, while lower magnitudes indicates the more significant attenuation of the corresponding frequencies. Okay, next, we move on to the second subplot. It displays the phase response of the RC low pass filter. The x-axis is also logarithmic scale, represent the same frequency from range 1 Hz to 10 MHz. The y-axis represent the phase shift introduced by the filter in degrees. The phase response indicates how the filter affects the phase of the input signal at different frequencies. So positive and negative phase shift can be observed, which corresponds to the delay or advancement of the signal phase caused by the filter. As for the code, I set the code to the 2 kilo ohms and 3 microfarads. Create the symbolic variable S, and this is the transfer function. Then I convert it to the transfer function into a MATLAB function is to analyze analyze the system response. This is just to deploy the frequency response. Already show the code of the transfer function and the output of the transfer function in MATLAB. And next, in the multi-sim, I create the RC low pass filter design, which is I set the resistor to the 2 kilo ohms and capacitor to the 3 microfarads. And this is the output that given.
Then, which SHARIFAH SAKINAH and my design between the two. For my filter, I choose active filter, which is the active high pass filter, where this high pass filter allows high frequency signal to pass throughout while activating or blocking the frequency signals. The capacitor threaten and resistant varies inversely with frequency, but the resistor can impact the filter gain and also the frequency response. Simultaneous response, observing the output signal when subjecting the filter to different input signal, the driving function will analyze the filter behavior such as the cutoff frequency, gain, and also the shift, and also circuit development, constructing the circuit to accurately represent the filter behavior for evolution. And so this is the first coding for the high pass filter. This is for the transfer function. This is the circuit that I will be using. And then this is the code that I made using the Python or Jupyter Notebook, and use the code. And in the end, this is the output for the transfer function. So from the transfer function, we can see that the filter will attenuate all the low frequencies and pass all the frequencies that are higher than the cutoff frequency, which is for this experiment is 100 Hz as calculated using half pi RC. And this limitation of the frequency response will depend on the bandwidth of the OPM, OPAFP, due to the gain and also the open loop characteristic of the optical value, which cause the filter to function as the biphasor, as shown in the output. You can see that this is the time for the x-axis and also for the y-axis, this is the amplitude. This is the code input numpy, x, and p, and then first I will define the parameters, which is the r and also the c. And then I create this inner input for the simulation by using the t equals to np and space 01 num and then this is simulate the start response of the active filter, and as for the plot the start response, this is the output that we will get. And then for transfer function, the code will be this one, where I define the parameter, and then I will calculate the coefficient of the high pass, and then I will create a signal input for the simulation, and then I will calculate the frequency response, plot the frequency response, and then I will plot the graph, and this is the output for the transfer functions. From this, we can see that the frequency response of the high pass increasing the based on the magnitude of the frequency. The higher the frequency, the magnitude will increase. Then we stop there, and that for the phase, this is what we get. Now we show you that video. This is the one, and this is the output. After we run the program, we get this as output, as I showed earlier. And then for the simulation, this is the solution that we did. I used the active high pass filter by using the 5T virtual optical amplifier with one resistor and so one capacitor. And then the resistor is 1 kilo ohm, and also the capacitor is 1 farad. And then this is the output that I get from the multi-sim, where this is the 4-channel oscilloscope output. This is the signal that we get. And then for the Broad plotter, this is for the magnitude and also the phase. And you can see that the output is the same as we got in the and the Jupyter. And by using the transfer function, the frequency response of the physical circuit is plotted. We can see that the magnitude curve and phase curve of the bird plot for high pass filter is this. And then we can show that the circuit behave as a high pass filter that allow high frequency and block low frequency. Then the output signal equivalent phase angle or phase shift is proceed of and the input signals. And I think that's all from me. Thank you so much.